In station 1, you were supposed to use a scale factor to find the new area of the scale drawing. So in letter A, our scale factor is 3. So remember, your scale factor is telling you what to multiply by. So since the first side is 2 meters, our new side would be 2 times 3, because this is the scale factor. So now in our new drawing, instead of having 2 meters on the side, this is 6 meters, because 2 times 3 is 6. And then for the other side, we have 4.5 meters. So 4.5 times 3 is 13.5. So our new side is 13.5 meters. So that's not all though. So that's only halfway there. We also have to find the area. And we find area by multiplying length times width. In this case, it's going to be 6 times 13.5. And 6 times 13.5 is 81. That is the area of the new figure. Now let's look at B. Our scale factor has changed. Now it's 1.5. But we're going to do the same thing, and conveniently, this triangle is an isosceles right triangle, which means both of the sides have the same length. So I really only need to find one dimension. So we're going to take 6, because that's the length, and we're going to multiply it by the scale factor. You'll notice throughout today's activity, we're multiplying by the scale factor because that's what a scale factor tells us to do. When we multiply 6 times 1.5, we get 9. So our new triangle is going to have lengths of 9. To find the area of a triangle, we have to multiply the base times the height. Oops. Here's the base, here's the height, so we have to multiply 9 times 9. And then we have to multiply it by 1/2. The area of a triangle is half of the base times the height, because a triangle is half of a square or a rectangle. We know the formula for that is length times width. So, getting back to this, 9 times 9 is 81, and we have to multiply by 1/2. And remember, when we multiply by 1/2, it's the same thing as dividing by 2. We multiply across 81 halves. And 81 divided by 2 is 40.5. So this is the area of the new triangle. All right, C is a circle. The formula for area of a circle is pi times the radius squared. The radius is this piece, and our scale factor is 2.5. So let's take care of that. We have 4 times the scale factor of 2.5, and 4 times 2.5 is 10. This is our new radius. This is our new radius. So pi, we're going to estimate that to be 3.14, because of course pi is irrational. It goes. We're going to multiply it times the radius squared. So that becomes 3.14 times 10 squared means 10 times 10, that's 100. And 3.14 times 100 is 314. And that is the area of the circle, 314 feet squared. For the last one, we have a parallelogram, and it has a height of 2.25. So we're going to take the height of 2.25 and multiply it by, you guessed it, the scale factor. In this case, it is 2. 2.25 times 2 is 4.5. Our other dimension is 5 centimeters. So we have to multiply that by the scale factor, which is 2. 5 times 2 is 10. So that gives us the dimensions of our new parallelogram. That's going to be 10 centimeters, and the height is going to be 4.5 centimeters. And we know that the formula to find the area of a parallelogram is the base times the height. So our base is 10 centimeters, opposite sides are equal. So that's going to be 10 centimeters times the height, which is 4.5. And 10 times 4.5 is 45. So the area of the new parallelogram is going to be 45 centimeters squared. Okay, on this page, they want you to find the perimeter of the figures using a scale factor of 2. So scale factor of 2. So that means we're going to multiply all of our dimensions by 2. And when we find the perimeter, we're going to add all the sides up. Now it's going to be the same process for all of these, so I'm only going to do the odd problems. So for number 1, we have a rectangle with dimensions of 2.4 by 6.5. So 2.4 and 6.5. And for both of these, we're using our scale factor of 2. So multiply both of them by 2. 2.4 times 2 is 4.8. And 6.5 times 2 is 13. So imagine in our new rectangle, the sides are 4.8 now, because they were enlarged with a scale factor of 2. And the long sides are 13. So now we just add up all of our sides. 13 plus 13 is 26. 4.8 plus 4.8 is going to be 9.6. And when you add those together, you get 35.6 centimeters squared, which matches with, which one is it? C. So number 1 goes with C. For number 3, it's a perfect square. I can tell because all of the sides are the same. We get 3 by 3. So that's nice. I only have to multiply by the scale factor once. Our scale factor is 2. 3 times 2 is 6. So in our new square, all 4 sides have a length of 6. I need to add all of those together because we're talking about perimeter. And let's see, 6 plus 6, well, let's see, it's 12 plus 12 is 24. You also could have realized that that's 4 6s and done 4 times 6 is 24. But either way, we get an answer of 24 centimeters squared, which matches with A. So 3 is A. All right, for number 5, remember I'm just doing the odd ones. We have lengths of 4.3. And let's see, the width is 2.5. Our scale factor is 2, so we're still multiplying by 2. 4.3 times 2 is 8.6, and 2.5 times 2 is 5. So imagine your new rectangle. The width is 5, and the height is 8.6. So to find the perimeter, we have to add all 4 of these numbers together. 5 plus 5 is 10, and then 8.6 plus 8.6 is going to be 17.2. And when we add these together, we get 27.2, which matches with, which one is it? With B. So number 5 is B. So to figure out the other 2, you're going to follow the same process. And you can see these are your only 2 possible answers left. So go ahead and try those and make sure you're coming up with the right answers. Okay, so for these 4, they're asking you to figure out which ones have an area greater than 140 square feet. So let's try these. They don't give you a scale factor, but they do give you the scale. So we can use that to figure out our scale factor. Where it says 1 inch is equal to 2.5 feet, what we have to figure out is what number times 1 gives us 2.5. Well, we're multiplying by 2.5. That's your scale factor. This is what we need to multiply each of our dimensions by, and then we'll find the area. So let's see, for the first one we have 12 by 3. So we're going to multiply 12 times the scale factor, which is 2.5, and then 3 times 2.5. Well, 12 times 2.5 is 30, and 3 times 2.5 is 7.5. Now, when we find area of a rectangle, our formula is length times width. So in this case, it's going to be 30 times 7.5. And when you multiply those together, you get 225. Now remember, our original goal was to see if it's greater than 140, which this one is. So we know that number 1 is going to be eligible for use for this architecture project. Let's look at number 2. Okay, for number 2, we have a triangle. And remember, the area formula for a triangle is half of the base times the height. So let's say our base right now is 6 and our height is 15. But what's our scale factor? Ooh, I don't know. Let's see. We have 1 inch is equal to 3 feet. So ask yourself, what times 1 gives you 3? Yep, it's 3. So this is our scale factor. So this is what we need to multiply each of our dimensions by. 6 times 3 is 18, and 15 times 3 is 45. Okay? Scale factor. So now let's use our formula. Area is half of the base, which, let's see, what was our base? 18 times the height. Half of 18 is 9. And 9 times 45 is 405. 405, what is that? Inches squared. Is this greater than 140? Because remember, that was our original goal there. It sure is. So we know that number 2 is part of the answer. Now I'm looking at our choices. Let's see. It could really be anything but B. It can't be B, right? Because we know that 1 is part of it. So we're going to have to keep going. We might have to end up doing all of these. Goodness gracious. That's okay. We have the strength. We can do it. In number 3, we have a rectangle. This is not an isosceles right triangle because we have different dimensions. We have 4.5 and 5. We have to figure out our scale factor. Yeah. Anyway, so 1 inch is equal to 4 feet. Clearly, our scale factor is 4 because 1 times 4 is 4, so that's what we're multiplying by. 5 times 4 is 20. 4.5 times 4 is 18. In case you're wondering, I already did my calculations earlier, that's why. I seem to be going kind of fast. So in our new triangle, these are our dimensions, right? Instead of 5, we have 20. Our height is 18. Our area formula is 1/2 times the base times the height. Half of 20 is 10, and 10 times 18 is 180. Is 180 greater than 140? Why, yes. Yes, it is. So this one could be used by the architect. So now that means we have to keep going and do the last one because our answer could be D. We don't know. It's either going to be C or D, isn't it? So let's keep going. Okay, our last one. This is tricky. This one was tough. So let me sketch it here. Let me fill it in. So those are all the parts they gave me. They didn't give me the dimensions here, but I can figure those out because this piece and this piece match up, and that's 5 and 3, which means this bottom piece has to be 8. Now, we first need to use our scale factor to make an enlarged area. And so, let's see, we have 1 inch is equal to 1.5 feet. To get from 1 to 1.5, we're multiplying by 1.5. So each of our dimensions, we have to multiply by 1.5 or 1.5. Every single one of these times 1.5. Okay. I'm going to do our new dimensions in green. How about that? So let's see. 5 times 1.5 is 7. I'm going to draw it over here. 7.5. 6 times 1.5 is 9. So this piece is 9. 3 times 1.5 is 4.5. And that gives me a couple of these. There we go. On the left where we had, oh, they didn't give us that one, did they? Is that 9? It is 9. So 9 times 1.5, that's 13.5. Our bottom piece we figured out was going to be 8, and 8 times 1.5 is 12. So now we have our new dimensions. Okay? And let's see, what are we doing? We're finding the area. This is not a regular rectangle, is it? So we can't do length times width here. We have too many lengths and widths. So here's what we're going to do. We're going to break it into 2 separate quadrilaterals. This one is going to be 12 times 4.5, or 12 by 4.5. So we'll find the area by multiplying 12 times 4.5. And 12 times 4.5 is 54. So that's this piece. And then on this one, this is going to be 9 by 7.5. 9 by 7.5. So that's what we have to multiply there. 9 by 7.5. And 9 times 7.5 is 67.5. So that's the area here. To find the area of the entire piece, we have to add that together. 67.5 plus 54. When we add this together, we get 121.5. That's for the whole area. Remember last year, you might remember having done composite, the area of composite shapes. That's what this is. But anyway, we end up with a total area of 121.5. That is less than 140. So 4 does not qualify. So your answer cannot be D. It can't be B because 1 and 3 qualify and not 4. Can't be 1 and 4 only, because 4 doesn't even qualify, so it has to be C. So I thought this problem was pretty fun. So first we have to figure out our scale factor. So we're going from original to new. We're going in this direction. So we're going from 6.2 centimeters is going to be equal to, so that's 6.2, is equal to 15.5 meters. So remember in our last station we were trying to figure out what we were multiplying, and it was easy because our first number had been 1 every time. But this one's not as easy. It's really not very clear at all. So the way we figure out our scale factor, the way we figure out what we're going to multiply, is we can use some division. So if you think about it, we're trying to figure out 6.2 times some number is going to equal 15.5. So the opposite of multiplication is division. So to figure out our scale factor, or our missing number, we can use division. We're going to take 15.5 and divide by 6.2. And you'll find when you divide those numbers, you get 2.5. So that means that 1 centimeter is equal to 2.5 meters. And now it's easy to see. Oh, we're multiplying by 2.5. So that was really the hardest part of this, wasn't it? Was figuring out your scale factor. So let's see. Let's see if we can eliminate some of our choices here. Let's see. This says the scale is 1 centimeters equals 2 meters. Chelsea is clearly in the wrong. This one says 2.5 meters is equal to 1 centimeter. No, that would be going the other direction. That's going the other direction. So it's important to make sure you're keeping your original on the left, isn't it? The last one, 1 centimeters is equal to 2.5 meters. That matches. This one is right. So I already know Jordan is right without having to do the rest of it. The only other piece was finding the area. Area you multiply. And we find that 15.5 times 6 is 93, which was the other piece of information. So there you have it. The answer here is Jordan. Good job, Jordan. This is very much like the first station. We have to use the scale factor, apply it to your dimensions, and then multiply to get your area. So the first one we have one of your dimensions is 3 and the other is 6. Your scale factor is 0.5. So we have to multiply by the scale factor. This is how you get your new dimensions, is by multiplying by your scale factor. Oops, I'm on the wrong page. So 3 times 0.5, which is the same as saying 3 times 1/2 is 1.5. And remember when we multiply by 1/2, it's the same as dividing by 2. So 3 times 1/2 is the same as 3 divided by 2, which is 1.5. And 6 times 1/2 is 3. Those are your new dimensions. Those are your new dimensions. So we have 1.5 here. Ooh, sloppy. To find the area, we multiply length times width. And 3 times 1.5 is 4.5 meters squared. So that was the first one. For the second one, we have a triangle. So I know the formula for that, if you remember by now, is half of the base times the height. Here, our original dimensions are 12 by 12. It's an isosceles right triangle. Multiply by your scale factor, which is 3/4. So when we multiply fractions, remember you've got that invisible denominator of 1. Multiply straight across. 12 times 3 is 36. 1 times 4 is 4. And remember this fraction bar tells you to divide. 36 divided by 4 is 9. So that means the new dimensions of your triangle are 9 by 9 instead of the what you started with, which was 12 by 12. And remember, that makes sense because as we've discovered, when your scale factor is a fraction that's less than 1, you're going to end up with numbers that are smaller. Your image is going to be smaller. If your scale factor is a whole number, you're going to make an image that's bigger. Anyway, let's find our area. Half of the base times the height. So let's see, it's easy to do 9 times 9, that's 81. And half of 81 is going to be 40.5. And that's the area for number 2, 40.5. Am I the right one? I keep losing myself. Yes, 40.5 inches squared. For number 3, you had to remember the area for a circle. It's pi r squared. And of course for pi we're going to round it to 3.14. So it's going to be 3.14 times the radius squared. This that they gave you, the 8 feet, that's your radius. Let's use our scale factor of 0.25. So we're going to take the 8 feet, multiply it by the scale factor, 0.25. And when you multiply that, we get 2. Now another way to look at this, 0.25 is the same as 1/4. So we can multiply across. That gives us 8 over 4, because 8 times 1 is 8, and 1 times 4 is 4. And again, that fraction bar tells you to divide. 8 divided by 4 is 2. So that's where that comes from. All right, and let's go back to our formula. So we're going to take pi times the radius squared. When we say squared, we mean to multiply 2 by itself twice. So 2 times 2, which is 4, and 3.14 times 4 is 12.56. And what were the units there? Feet squared. So that's the answer to C. All right, last one for station 5 is a parallelogram. The area for the parallelogram is going to be base times height. The base that they give us is 6 by 24. We're going to multiply by our scale factor, which is 1/3. Remember, this is the same as dividing by 3. So you multiply across, you get 6. 1 times 3 is 3. See, we're just dividing by 3. 6 divided by 3 is 2. Multiply across, you get 24/3. 24 divided by 3 is 8. So that gives us our new dimensions for the parallelogram. So there's our height of 2, our length of 8. And we multiply 8 times 2, which is 16. So the area for the parallelogram is 16 centimeters squared. Okay, for each of these, we have a scale factor of 1/2. So we have to multiply each of our dimensions by 1/2. And we're looking for perimeter. And they even tell you it's going to be a reduced figure because, as we mentioned, when your scale factor is a fraction, you're going to end up with something smaller. So let's take a look. We have dimensions of 5.8 and 8. We're multiplying by the scale factor, which is 1/2. So let's see, half of 5.8 is 2.9, half of 8 is 4, and we're going to do all the way around. So that's 2.9, there's 2.9, there's 4, there's 4. When we add 4 plus 4, we get 8, and we add 2 plus 9 plus 2.9, we get 5.8, and when you add these together, you get 13.8 centimeters. And notice it's not squared. We only get units squared when we're doing area. All right, that's the first one. I'm going to do the odd ones again because it's the same procedure. Oops, I missed some. Sorry. So for this one, it's a square that's 4 by 4. That's nice. We only have to multiply by one number. 4 times 1/2, or 4 divided by 2 is 2. So our new square has side lengths of 2. And 2 plus 2 plus 2 plus 2, or 4 times 2, is 8. So the second one, or I'm sorry, number 3 is 8 centimeters, not squared. Oh, I forgot we have letters. So let's see, number 3 is B. What did we say A was? Oh gosh, let me see. It was 13.8, which was D. All right, let's try number 5. For number 5, we have dimensions of 7 by 3. We're multiplying by 1/2. That was our scale factor. And you know, instead of using the fraction, you could also use the decimal. If you're using your calculator to check your computations, you can use that for 1/2. They're the same thing. 7 times 1/2 is 3.5. 3 times 1/2 is 1.5. So remember, we have our new rectangle. Okay, I drew it the wrong way. We have our new rectangle. So this is going to be 3.5 on this side, 1.5 on that side. Opposite sides are equal because it's a rectangle. And we just have to add all the way. So 1.5 and 1.5 is 3, 3.5 and 3.5 is 7, which gives you a total of 10, which is C. And that's how you do station 6. All right, we're back to our favorite architect. We're still aiming for 140 square feet. So we're doing area. Now we have different numbers. So let's try this one out. Our scale factor, let's see, we have 1 inch is 3 feet. So what is the scale factor? Yep, it's going to be multiplying by 3. Our scale factor is 3. Our dimensions are 6 and 2. That gives us 18 and 6. And we're doing area, right? Yes. So the area of a rectangle is length times width. So that's 18 times 6, which gives you 108. That is not big enough. So right off the bat, we've eliminated number 1. So that takes care of choice A, doesn't it? It can't be A because that included 1. It can't be C because that included 1. And it can't be D. That's all of the above. Well, that's weird. So it's going to have to be B. Well, that was fast. So in order to solve the rest of them, it would be the same way. Let's do number 2 just for kicks and giggles, shall we? Okay, let's try 2 because this is going to verify that B is the right answer. I mean, clearly it can't be anything else if you eliminated number 1. So in the triangle, we have our dimensions of 6 and 2. So 6 is the base and 12 is the height. The scale factor, where 1 inch is equal to 2 feet. We're multiplying by 2, so that's your scale factor. So let's multiply these by 2. That gives you 12 by 24. So imagine your new triangle, much neater than that, of course, has a height of 24 and a width of 12. Right? Yes. Our area of a triangle is half of the base times the height. So that's going to be half of 12 times 24. Well, half of 12 is 6. So we're really just multiplying 6 times 24, which gives you, oh gosh, let's see, 144, right? Yes. 144 inches squared. And that is bigger than 144, so we were right. It has to be B, and we don't even have to do any more work. I mean, you can, right? Like, that's going to be allowed. But we've already figured out our answer. All right, moving on. Last station. All right, this is kind of like the other station we saw. We have to figure out the scale factor. And I can tell we're going from big to small. So I'm expecting my scale factor to be a fraction. So let's see, I'm going to use the top numbers to compare. We're going from 20 meters to 5 centimeters. Do you remember how to find your scale factor? Yep, we're going to have to divide because we're trying to figure out what number times 20 equals 5. So some number times 20 has to equal 5. So to figure that out, we're going to divide both sides by 20. So our some number, this ends up being your scale factor, is going to be equal to 5 divided by 20, which if we use our common factor, we can simplify this, dividing both of these by 5. 5 divided by 5 is 1, and 20 divided by 5 is 4. So our scale factor is 1/4. Now, remember, we talked about this. These are reciprocals. Sometimes it's easier to recognize going backwards. If you know your tables, you might have recognized, wait, 5 times 4 is 20, but that's going from new to original. That's backwards. That is not the scale factor. But if you know this, then you might be able, hopefully, to come up with the reciprocal. So going this way is times 1/4. These are reciprocals. Do you remember talking about that in class? My dogs are going crazy. Ignore them. So now we have our scale factor. Let's see if that helps us. So we know now that 1 meter is equal to 1/4 of a centimeter. That's our scale factor. So let's see if that matches. 1 meter, let's look. Tanner says the scale is 1 meter is equal to 4 centimeters. That's wrong. He's going backwards, isn't he? He's going from new to original. That's not what we're doing here. Tori, on the other hand, says 1 meter is equal to 1/4 of a centimeter. Ooh, that's true. That's good. But wait, Michael says the same thing. Michael also says 1 meter is equal to 1/4 centimeter. So we got to do a little more work here. We have to figure out the area of the new figure. So let's see, our new figure is 5 centimeters by 3 centimeters. An area of hold on. Okay, sorry you had to hear that. I think they're going to behave now. The big one was attacking the little one. Anywho, so we were looking at the dimensions of the new figure. It's 5 by 3. And the area of a parallelogram is going to be base times height. So our base is 5 times the height of 3 is 15. So let's see, who was right? Tanner says, I'm sorry, Tanner's completely wrong. But Tori says the area would be 24. That's not right. It's 15. So it can't be Tori. Michael did it. He got the right answer. So Michael is the star of the show. He gets it right. So that's how you solve pretty much all of the problems from today's review activity. If you still have questions after watching this video, please ask me during workshop time. Thank you.